Lilac is the name that the paper company gives to that color paper. Lilac is that.
We're the most colorful team.
Wait, what? You say wait?
Well, you
Wrong shirt.
stay up for
Kevin did not wear a blue shirt. Brian did not wear a white shirt. Jared, that's not a gold shirt. And here we have Lilac wearing a dark blue shirt.
Or brown for our coup.
Apparently mine. No, it's the sand disc. Problem. Unless it's something good. That's Brian, by the way. Brian was trying to sabotage me. Way to go. Alright, Timmy Collins. I'm going to represent the Lilac team. And we had the step response curve stuff here for filter wash station with both control valves closed. Alright, the background, we're going to go over the inputs, the outputs, the steady state operating conditions. The theory, we're going to give you the parameters for our experiments, and we're going to give you the results and conclusions. Alright, for our system, I stated earlier that we have both valves closed. That means this control valve here, this control valve here, basically not going to be operational. We have our input on the control panel here, sends a signal to the motor controller to operate. It pumps water out through the nozzles, and then as that's working, this transmitter here tells the computer on the control panel what's happening. And it transmits in pounds per minute is what it's measuring here. Alright, our operating range is going to start at 40% and go to 100%. We have on here the steady state operating curve, starting at 20. As you can tell, 20 kind of dips down a little bit down here at the bottom, and starting at 40, it's a lot more linear. So we're going from 40 to 100%. Under 40 just doesn't give good results. Our block diagram here, we're going for our percentage, 40%, 55%. Each 15% each one into the system, and we're getting an output measured in pounds per minute. This is just a sample of the steady state, just a straight line, nice and boring. Alright, each trial we did 15% up. And then once we got to 100%, we did 15% down, starting at 40 to 85, and then when we got to 100, we went from 100% down to 55. All right, this is just a sample from 75 to 85%, just one trial. As you can tell, we got steady state starting at about 6 seconds or so, and right at about 20 is where the step response actually starts. This is our input here, 70 to 85. Our dead time is about 0.9 seconds, and our time constant was about 1 second, give or take, in most of the experiments. Our gain isn't very high. It's only 0.2 pounds per minute throughout most of the experiments. This is just telling you like about the graphs that are coming up. The graphs that we're generating in the next few slides are an average of 3 trials per power input. There's uncertainty bars on each one of these bar graphs. They are using the student's principal at 95% confidence level. The left bars are the step-up values, 15%, and the right bars are the step-down values of 15%. This is the gain. As you can tell, like as it starts, the gain is a little higher, and as it goes down, the gain gets a little less. But you notice the 70 to 85%, for some reason, it didn't quite turn out the way that we thought it would, as being linear all the way across. And you can see that in all of the graphs pretty much, that 70 to 85% is a little off. This is the step here, and you can tell again 70 to 85% is not quite in line with the rest of the information. It starts off higher and then goes down. You can also see the uncertainty on the second 85% is a little high as well too. And then you can really see that 70 to 85% on this graph is way out. All right, we start off just like all the other ones, the T0 in seconds. It starts off high and it kind of tapers off, with the exception of 75 or 70 to 85%. Now, the time constant on this, it averages around 1 second, give or take. All the data is pretty much similar, but we get here like 75 to 85 is back in range, but 85 to 100 is out of range. And then the error bars support that 1 being a good number for the time constant. For the conclusions, we figure the large uncertainty is due to the eyeballing of the graphs. Also, 4 different people ran 3 different trials at several different times. We ran half the data, then we had a motor problem, and then a few days later we ran the data again. So that's where we think most of the inconsistencies in the data come from. I think if we ran it all at the same time, we probably would have had better data. I stated before that the time constant for all the data up and down is around 1 second. And for our power, as the power increased, the gain decreased. And that went as well as far as going up 15% and going down 15%. So this is just a chart showing what we calculated to generate the graphs from before. It's just showing the standard deviation, the averages, nothing special.